Hi children, today our teaching topic is Algebra for Beginners. Origin. Algebra began in ancient Egypt and Babylon. Diophantus 3rd century AD, a Greek mathematician, is the father of algebra. Arithmetica is his brainchild book. Francois Viette, 16th century French mathematician, developed it as modern algebra. He used English alphabet to represent unknown numbers called variables. Introduction to new terms: coefficient, constant, and variable with individual patterns. Like and unlike terms with some objects and animals. Formation of rules with the help of combined patterns. Formation of rules from geometry and mensuration. Synonyms for four fundamental operation symbols. Formation of algebra expressions. Please visit my blog rpmathhunt.blogspot.com for more videos. Now, nature of the algebra. Arithmetic. 2 plus 3 is equals to how much? The terms in the question are known. Answer is unknown. That is arithmetic. We go from known to unknown. In algebra, 2 plus what gives us 5. Terms in the question are unknown, but answer is known. Now, coefficient. Pattern 1. Vamsi and Rohit were making human faces as shown in the figure. They used 2 red stickers for eyes to make one face. Now, is 1, 3, 4, 5. But how many eyes are required? 2, 6, 8, 10. Just observe, for one face, 2 red eyes. 3, 6, 4, 8, 5, 10. Every time we multiplied by 2, 2 star number of faces is equals to 2 into n. Here 2 is coefficient, constant. N is changing or varying, that is called variable. Now observe pattern 2 also, my dear children. Padmaja and Shailaja were making triangles using matchsticks. They used 3 matchsticks for one triangle as shown in the figure. They are preparing. Observe on the screen how many triangles they are preparing. Number of triangles. 1, 2, 3, 5. How many matchsticks are required? For one triangle it is 3, for 2 it is 6, for 3 it is 9, for 5 it is 15. Now each pair have multiplied by 3. 1 3 is a 3, 2 3 is a 6. Here 3 into triangles is equals to 3 into t, 3t. Here 3 is constant or coefficient, t is varying, that is the reason it is variable. Now observe one more pattern. Vaishnav and Vaibhav are making squares using toothpicks. They used 4 toothpicks for one square as shown in the figure. Now observe the number of the squares prepared by Vaishnav and Vaibhav. Squares 2, 4, 6, 8. For 2 squares, how many sticks they used? 8, 16, 24, 32. Now observe what is the constant term. Here is a 4. 4 into square, that is 4s. 4 is coefficient or constant and s is varying, that is the reason it is variable. Now, like and unlike terms with some objects and animals. My dear children, observe on the screen 2 cows and 1 cow. Can we add them? Yes, we can. It is 3 cows. Now, 3 biscuits, 2 biscuits. Can we add them? Yes, they are 5 biscuits. Now, 3 biscuits and 2 chocolates. My dear children, can we add them up? Why? It is neither 5 biscuits nor 5 chocolates. It is 3 biscuits plus 2 chocolates forever. Now, observe what we have observed previously. 2 cows plus 1 cow is equals to 3 cows. 3 biscuits plus 2 biscuits, 5 biscuits. Why? The above 2 can be added. Yes, they are same things. They are called like terms. And again in this example, 3 biscuits and 2 chocolates. Why? The above 2 could not add since they are different things. So they are called unlike terms. Variables, any English alphabet letter is used as a variable. Instead of things or objects or unknown numbers, we can substitute them. Here 2 cows, I am replacing with x variable. Here 1 cow, replace with x. Now can we add them? 2x plus 1x is 3 cows, that is 3x. Yes, we can add. Another example, biscuits, instead of biscuits I am substituting y. 3y, 2 biscuits, 2y. Then can we add them? Yes, we can. 5y, 5 biscuits, 5y. And 3 biscuits, 2 chocolates, 3b plus 2c. It cannot be added, it will be kept like that, 3b plus 2c only. Because they are unlike terms. Since they are different letters are unlike terms. Now, my dear children, observe 2 figures on the screen. Mixed grain means every grain is intermixed with one another. Now, after separation, how it looks? Yes, it looks wonderful. And aim, making unknown words into household terms. Introducing unknown terms without explanation. The child only concentrate on collection of objects, on color and sameness of letters. They have to pick like terms. So, x plus 1 whole square is not equal to x square plus 1 and a plus b whole cube is not equal to a cube plus b cube can be discriminated by them later. Now, observe, my dear children, on the screen. I am just providing some things to you. You have to separate them, those objects. You don't spell them, you don't read them, but just separate into like terms. Now, observe. X square y plus x square y plus x square y is equals to 3 of x square y's. and x square plus x square, 2x squares were there. Now xy plus xy plus xy plus xy plus xy. How many xy's? 5 xy's are there in the box. X plus x plus x plus x. How many? 4x. X by 4, x by 4, x by 4, x by 4. How many x by 4's are there? 4x by 4's. Yes, 4 gets cancelled and x will be remain. 1 plus 1 plus 1 is equals to 4. Yes, my dear children. Half plus half plus half plus half. 4 halves are there in the box. That is 2. My dear children, similarly, I gave one more problem on the screen. Separate like terms from them. Now, observe some variables were also given on the screen. Previously, it was in the picture form, but in the verbal form I am providing you. You have to separate like and unlike terms from these 3 problems. Now, formation of rules with the help of combined patterns, triangle paths. My dear children, observe carefully on the screen. 1. Triangle is formed with the help of 3 sticks, 2, 5, 3, 7, 4, 9. Then observe the constant term is 2. For one triangle, 2 into 1 plus 1. 2 triangles, 2 into 2 plus 1. 3 triangles, 2 into 3 plus 1. For 110 triangles, 2 into 110 plus 1. For n triangles, 2 into n plus 1. Yes, for n triangles, 2n plus 1 matchsticks were needed for him. And for 110, 221 matchsticks were needed. Observe one more pattern, combined pattern, square paths. Here 1 square 4, 2 square 7, and 3 squares 10. You count them individually, you will get 10. For 4, 13. How can we say? With the help of standard term or constant term. 3, 3, 3 differs. Therefore, first square, 3 into 1 plus 1. Second one is 3 into 2 plus 1. Third one is 3 into 3 plus 1. And n squares were there. Then 3 star n plus 1 squares are required to make that square path. For 84 squares, 3 into 84 plus 1. 253 for 84 square paths. Now assessment. My dear children, observe some patterns on the screen. And we have generalized a rule for previous 2 pictures. Now it is turn to you to do. If you did not get, take your class teacher's help. Now, formation of rules from geometry and mensuration also. Perimeter is the sum of the lengths of any closed figure polygon. A, B, C. Scalene triangle. Its perimeter is equals to A plus B plus C. Another triangle is isosceles triangle A, A, B. Then what is its perimeter? A plus B. That is, like terms 2A's are there. So you add them up. 2A plus B. And now, equilateral triangle A, A, A. Now, perimeter is equals to A plus A. That is equals to 3A. Now, perimeter of equilateral triangle is 3A. Now, square. Each side is having S units. Therefore, perimeter is S plus S plus S plus S. That is 4S. Now observe the net diagram of a cube. Each face is a square. S square, S square, S square, S square, S square, S square. Now what does lateral surface area mean? Lateral surface area of a cube is the sum of all flat surfaces of it excluding its top surface area and bottom surface areas. LSA, S square plus S square plus S square plus S, that is 4S square. Total surface area of a cube is sum of the areas of all flat surfaces in the object. That is LSA plus S square plus S square. That is 6S square units. Now my dear children, write LSA and TSA of cuboid. Every measure was given on the screen. This is length, breadth, height. Besides net diagram, BH, LH, BH, LH is BL, BL. Vocabulary for addition: sum, total, more than, greater than, together, all together, combine, how many in all or in all, increased by. These words tells us addition, subtraction, difference, minus, less than, fewer than, reduce, shorter, last, how many left, remain, decreased by, take away. And these are all the words tells about the subtraction. Now multiplication by dimension times. Multiplied by of, product twice, double, thrice, triple, set off, division, quotient, share, percent, per, ratio. Separated, distribute equally. My dear children, observe these words which gives you the sense of each operation while you read the problem. In the given problem, if any such terms were seen, you have to understand that particular operation or concept is involved in that problem and we have to choose that operation. Now, formation of algebraic expressions from the given verbal statements. 1. Add x and 5, that is equals to x plus 5. 2. Add x comma y and 5, that is x plus y plus 5. 3. Subtract 5 from x minus 5, and subtract x from 5 minus x. And fifth one, multiply x and 5, that is 5x. Some more. 6. Add 2 times of x and 5, 2x plus 5. 7. Add twice of x and 5, that is 2x plus 5, both are equal. 2 times or twice. Subtract 7 from thrice of q, that is 3q minus 7. 9th, multiply t and s, t into s. And 10th, quotient of x and 5, that is x by 5. Or we can say this is x divided by 5. 11. Same. Y is multiplied by 10 and then x is added to the product. That is 10y plus x. 9 times n is added to 10. 9n plus 10. Write statements for each given expression. 1. 10 by y plus x. 2. 5n minus 10. 3. 5 plus 2x. 4th. 4x by 5. Simple equations. Equations has sign of equality between its two sides. Expression. The value of the left side of the equality sign is called left hand side or LHS. And the value of the right side of the equality sign is right hand side. So it is called as RHS from now. Here 2m is equals to 10 is an equation. What is LHS? 2m is LHS, 10 is RHS. Now just like pan in the common balance, left hand side, right hand side, both are equal. 2x plus 5 is equals to 15, LHS is equals to RHS. Then 3p plus 5 is equals to 2p plus 10. Which one is LHS? 3p plus 5 is LHS, 2p plus 10 is RHS. Root of the equation by trial and error method. The solution of the equation is the value of the variable for which LHS and RHS are unequal. The solution is also called as a root of equation. Example, 2m is equals to 10. You have to substitute every time one after the other. Constant. 2 into 1 is equals to 2. At m is equals to 2 into 2 is equals to 4. At m is equals to 3. 2 into 3 is equals to 6. At m is equals to 4. 2 into 4 is equals to 8. And at m is equals to 5. This right, 2 into 5 is equals to 10. Both sides, it is. Yes. It holds good. At m is equals to 5 holds good for the equation 2m is equals to 10. So they are equal. 2 into 5 is equals to 10 is equal. Root of the equation. For another problem, 2x plus 5 is equals to 21. Now at x is equals to 1, 2 into 1 plus 5 is equals to 7. At 2 into 2 plus 5, that is 9. At x is equals to 3. 2 into 3 plus 5. 6 plus 5 is 11. 2 into 4 plus 5. That is equals to 13. 2 into 5 plus 5 is equals to 15. M is at x is equals to 16. That is 17. At x is equals to 7. That is 14 plus 5. 19. 8. At 8. 2 into 8 plus 5. 16 plus 5 is equals to 21. Yes, it is right. All are not equals. But 2 into 8. At x is equals to 8. It is equal. So it is the root of the solution. 2x plus 5 is equals to 21. Now assessment. My dear children, observe on the screen carefully. Find the roots of the given problems. If you can, you do. Otherwise, you ask your class teacher. Now, word problem solving strategy or problem solving math. Read the problem carefully and thoroughly. Write tough words in the problem. Next one, given data. Write the data values in that box. And third one is the concepts involved in the given problem in the third box. And next, fourth box. Now, obtaining the problem by simplification methods. Or the child obtains the solution by simplification. Thank you, my dear children.